In this lesson, we will solve systems by substitution. In the last lesson, we learned how to solve systems by graphing. So we put both of the lines on a coordinate plane, and we found the solution by looking to see where those two lines intersected. Today, we're going to use another method to find the solution. We're going to use a method today that is called substitution. It will get us to the very same answer we would find if we graphed. It's just another method to get to the very same answer. When we use the method called substitution, when we look at our two equations, we're going to look for the one that starts with an x equals something or a y equals something. We want to choose the equation that's already written in that format. And so you can tell as you look here at this first example, the equation that's already written in that format is this second one. It says x equals negative 3y plus 11. What we're going to do is that equation tells us what x equals. X is equal to negative 3y plus 11. So we're going to go to the other equation, and where we see the letter x, we're going to substitute what x is. We're going to actually fill in what x is supposed to be. So I'm going to write 2 instead of times x. I'm going to fill in what x is. X is negative 3y plus 11. Now I'm going to copy the rest of the equation as is. Minus y equals 1. Now I'm going to solve that equation. 2 times negative 3y is negative 6y. 2 times 11 is 22. I'm at the end of my parentheses, so I'm finished distributing. Now it looks like I can combine like terms. I have negative 6y and negative 1y. So let's combine, make that negative 7y plus 22 equals 1. Now I can take away 22 on both sides, so that I end up with negative 7y equals negative 21. I can divide by negative 7 on both sides, and I find out that y equals 3. Now remember, when we find a solution, we're looking for an ordered pair, right? We're looking for that ordered pair where these two lines would intersect. So in my ordered pair answer, I have found the y coordinate. I know that y equals 3. Now I need to find the x coordinate. So I'm going to go back to that original equation that says x equals negative 3y plus 11. And I'm going to plug in what I now know. X equals negative 3. And instead of y, I'm going to plug 3 in, right? We just found out that y equals 3. So I'm going to plug that in. This will tell me what x is. X is equal to negative 9 plus 11, which means x is equal to 2. So now I have the other half of my ordered pair. I know the solution is 2, 3. Now I can always check that by substituting 2 and 3 into either of the two equations. It needs to work in both. Chances are good, if I've done my math right, if it works in one, it's going to work in both. Let's substitute it back into that first equation. If we use that first equation, we would have 2 times 2 minus 3 equals, whoops, I don't need that other parentheses, equals 1. Let's see if that's true. 2 times 2 is 4. 4 minus 3 does equal 1. So I know I found the correct solution. Okay, let's look at another example together. 2x plus 3y equals negative 13, and y equals x minus 6. Remember, we want the equation that either begins with x equals something or y equals something. And it looks like we're going to have a y equals x minus 6. So we're going to take what y equals and we're going to substitute it into the other equation. 2x plus 3, and instead of writing y, I'm going to fill in what y equals. Y is x minus 6, right? I just substituted in place of y what y is. And then I have my equal sign and my negative 13. Now let's solve that. 2x plus 3 times x minus 18, right, I just distributed, equals negative 13. I'm going to combine my like terms to get 5x minus 18 equals negative 13. I'm going to add 18 to both sides so that I get 5x equals 5. To solve for x, I divide by 5 on both sides, and I find out that x equals 1. So the first number in my ordered pair is 1. My solution is 1 something. Now let's take that answer and let's go back to the original equation. Y is equal to, instead of x minus 6, let's fill in 1 minus 6, which means y is equal to negative 5. So my solution is 1, negative 5. Now let's check our math and make sure we did it right. 2 times 1 plus 3 times negative 5 equals negative 13. Let's see if that's true. 2 plus negative 15 equals negative 13. Negative 13 equals negative 13. So we have done our math correctly. The solution is 1, negative 5. Let's take a look at one final example together. The first equation is in the correct format. It's in the format of y equals x plus 3. So y is equal to x plus 3. Let's take that and substitute it into our second equation. Negative 3x plus, let me change back to black here, negative 3x plus 3y. So instead of y, I'm going to fill in x plus 3 there because that's what y equals. Now let's solve. Negative 3x plus 3x plus 9 equals 4. Negative 3x plus 3x is 0. I have 0 x's. Okay, 0x means I have no x's whatsoever. All I have is this equation that says 9 equals 4. That's not true, right? 9 does not equal 4. What that means is that this is a system that does not have a solution. These two lines would never ever cross. Remember, on a graph, we can tell, when we graph the lines, we can see, oh, these are never going to cross. When you solve by substitution, if you eliminate one of the variables, like we eliminated the x's, that means this is a system that has no solution. These steps are the steps that we followed on each of the 3 examples I just walked through with you. I simply have them in writing so that you can refer to them as you're doing your work in class.